Let's examine what happens when a solution becomes saturated. The solvent particles break the solute particles apart and diffuse them through the solvent. At the same time, some of the solute particles combine and return to the solid phase. This process is called precipitation. As more solute dissolves, the number of particles recombining increases until the rate of precipitation equals the rate of dissolving. What is the state called when two opposing processes occur at equal rates? The system is in equilibrium. The point at which dissolving and precipitating achieve equilibrium is called the saturation point.
The maximum amount of a substance that can be dissolved in a specific amount of solvent at a certain temperature and pressure is called the solubility of that substance. Here are some solubilities.
Solubility varies with temperature. A solubility graph shows how much solute can be dissolved in a given amount of solvent for a range of temperatures. This graph shows that the solubility of potassium nitrate is 50 grams per 100 grams of water at 30 degrees Celsius. But 110 grams can be dissolved in 100 grams of water at 60 degrees Celsius. The temperature of the water affects the amount of dye that will dissolve. The dye is more soluble in hot water. All of the dye dissolves in hot water, but in cold water, some of the dye remains undissolved. Even after 15 minutes, the dye in the cold water has not all dissolved.
Temperature affects not only the rate at which a solute dissolves, but also its solubility. As temperature increases, what happens to the solubility of a solid in a liquid? Solubility of a solid in a liquid generally increases with temperature. The degree to which it is affected varies greatly.
Tap water contains dissolved oxygen. Let's take a look at the effect of temperature on the solubility of gases in liquids. The water will be warmed evenly in the microwave, but not nearly to the boiling point. Tiny bubbles have formed in the warm water. The bubbles are oxygen that has come out of solution. As temperature increases, what happens to the solubility of a gas in liquid?
In general, gases are less soluble in liquids at higher temperatures. Can you explain this? When a solution warms, kinetic energy increases. The force of attraction between the gas particles and the solvent particles are not strong enough to hold the gas in solution, so a greater number of gas particles escape and return to the gas phase. When the liquid is cold and the system is at equilibrium, the number of gas particles escaping the liquid in a given time is equal to the number of gas particles entering the solution. In terms of equilibrium, what happens as temperature rises? As temperature rises, the number of gas molecules escaping in a given time becomes greater than the number of gas molecules entering the solution until a new equilibrium point is reached.
This soft drink contains carbon dioxide gas in solution at high pressure. What will happen when I remove the cap? Removing the cap releases pressure, and some of the carbon dioxide bubbles out of solution.
What can you conclude about the effect of pressure on solubility of a gas in a liquid? Solubility of a gas in a liquid generally increases with pressure. An equilibrium has been established inside this bottle. This means that just as many carbon dioxide molecules are coming out of solution in a given time as are dissolving into solution. Since the pressure inside the bottle is high, the solubility of carbon dioxide in the liquid is also high.
The system is opened. The pressure of the carbon dioxide dissolved in the solution is much higher than the pressure of carbon dioxide in the atmosphere, so some of the gas bubbles out of solution. When the top is replaced on the bottle, the pressure inside the bottle is lower than it was before. Gas molecules will come out of solution, building up pressure inside the bottle until a new equilibrium is reached.